Between the orbits of Mars and Jupiter lies a vast, empty space, filled with the ghosts of a forgotten world. For centuries, we've seen it as a junkyard of cosmic debris, leftover material from the birth of our solar system. What if it's a crime scene? In the 18th century, a strange mathematical law predicted that a planet should exist in this exact spot, a missing sibling in our celestial family. When astronomers pointed their telescopes to this void, they didn't find a planet. They found a swarm of rubble. This gave birth to a dark and captivating theory that the asteroid belt is not leftover material, but the gravestone of a lost world, a fifth planet that was violently obliterated in a cosmic catastrophe. Shattered remains now orbiting the sun as a permanent, silent memorial. This is the story of Phaeton, the planet that might have been. A story that pits a beautiful, terrifying theory against a scientific truth that is, perhaps even more profound. To understand where the idea of a lost planet came from, we have to go back to the 1700s. This was the age of reason. A time of Newton and Kepler, when the universe seemed to be a perfect clockwork machine, governed by elegant and divine mathematical laws. Astronomers were obsessed with finding the hidden patterns that dictated the heavens. In 1766, an astronomer named Johann Daniel Titius discovered one such pattern, a simple but bizarrely accurate mathematical sequence that predicted the distances of all the known planets from the Sun. This formula, later popularized by Johann Bode and known as the Titius-Bode law, worked perfectly for Mercury, Venus, Earth, Mars, Jupiter, and Saturn. But it revealed a glaring, undeniable hole in the clockwork. The law predicted, with absolute confidence, that there should be a planet orbiting in the vast gap between Mars and Jupiter. But when astronomers looked, there was nothing there. This missing planet became one of the greatest astronomical puzzles of the age. So, in the year 1800, a group of leading European astronomers formed a society they called the Himmelspalas, or the Celestial Police. Their sole mission, to hunt down this planetary fugitive. The hunt didn't take long. On January 1st, 1801, an Italian astronomer named Giuseppe Piazzi, while charting stars, stumbled upon a small, moving point of light right where the Titius-Bode law said a planet should be. He had found it. The world celebrated. But the celebration was short-lived. This new world, which he named Ceres, was tiny, far too small to be a proper planet. The mystery deepened. Just 1 year later, the situation grew even stranger. Heinrich Olbers, a member of the Celestial Police, discovered another object, Pallas, in the same orbital region. Then came Juno in 1804 and Vesta in 1807. It wasn't a single planet. It was a swarm of them. It was Olbers who proposed the radical theory that would dominate scientific thought for the next 150 years. He argued that these weren't thousands of tiny asteroids or star-like objects. They were the shattered remains of a single, much larger planet that had once existed in that orbit, a planet that had been destroyed. He named this hypothetical world Phaeton, after a tragic figure from Greek mythology. Phaeton was the son of the sun god Helios. To prove his divine parentage, he begged to drive his father's sun chariot for a day. But the boy was too weak to control the fiery horses. He lost control, veering too close to the earth, scorching it and creating the Sahara Desert. To prevent the destruction of the entire world, Zeus was forced to strike Phaeton down with a thunderbolt, shattering the chariot and killing the boy. The Phaeton hypothesis was a perfect, elegant, and terrifying explanation. It accounted for all the evidence. It explained why there was a belt of rubble where a planet should be. It provided a simple source for the thousands of meteorites that fall to Earth every year. They were simply chips off the old block, cosmic shrapnel from this ancient cataclysm. For over a century, textbooks and encyclopedias presented the destruction of Phaeton as the most likely origin of the asteroid belt. It was a story of cosmic hubris and destruction, a planetary tragedy written in stone and dust. But the 20th century, with its more powerful telescopes and new methods of analysis, would reveal a different story. The case against Phaeton began with a simple question of mass. If you could gather up every single piece of rock and dust in the entire asteroid belt, from the dwarf planet Ceres down to the smallest pebble, how big would the resulting planet be? The answer was the first nail in Phaeton's coffin. Altogether, the asteroid belt contains only about 4% of the mass of Earth's moon. It's simply not enough. its material to be the remains of a significant, differentiated planet. The crime scene didn't match the scale of the crime. Then came the second blow: chemistry. Using modern spectroscopy, scientists can analyze the light that reflects off asteroids to determine what they're made of. If they were all fragments of a single large planet, they should be chemically similar. A large planet would have differentiated with a heavy iron core and a lighter rocky mantle. But the asteroids are a chaotic mix. Some are dense and metallic, others are light and carbon-rich, and still others are stony. They didn't come from a single shattered body. They were a collection of different building blocks that had never come together. So if Phaeton wasn't destroyed, why is the asteroid belt there at all? The answer lies not with a mythical, destroyed planet, but with a very real, very powerful giant next door. The real culprit was Jupiter. The planet didn't get destroyed. Immense tyrannical gravity of Jupiter prevented it from ever forming in the first place. 4.5 billion years ago, as the solar system was forming, small dust grains clumped together into planetesimals, the building blocks of planets. Everywhere else, these planetesimals gently merged, growing larger and larger to form the planets we see today. But in the region between Mars and Jupiter, the gravitational influence of the gas giant was catastrophic. It acted as a massive cosmic bully, stirring up the planetesimals, flinging them around like a child in a sandbox, and accelerating them to speeds of thousands of miles per hour. Instead of gently coalescing, they smashed into each other with devastating force, shattering each other into the rubble we see today. Jupiter's gravity also ejected the vast majority of the original material from the belt, scattering it into the outer solar system. So we arrive at a new and perhaps more profound truth. The asteroid belt is not a planetary graveyard. It is a planetary nursery that failed, a world that was violently prevented from ever being born. The fragments we see today are the planetary embryos. It's frozen in time for 4.5 billion years. It's offering us the most pristine glimpse we have into the raw materials that built our own world. The story of the asteroid belt is a story of our solar system's violent and chaotic youth. But it also reveals why we have a stable home today. Jupiter, the cosmic tyrant that prevented the birth of a fifth planet, may also be our great protector. Its immense gravity acts as a shield, deflecting or capturing countless comets and asteroids from the outer solar system that could otherwise be on a collision course with Earth. The planet Phaeton was a myth, a beautiful story created to explain a mystery. But it was a placeholder for a deeper truth about the immense forces that shaped our solar system. The asteroid belt isn't the ghost of a dead planet, it's the ghost of a world that never was. And it forces us to wonder, as we look out at other star systems, how many other asteroid belts are out there? How many other worlds are being held in a state of arrested development, their birth forever denied by the shadow of a colossal neighbor? The destruction of a planet makes for a great story, but the prevention of one tells us so much more about our own unlikely existence. If you were captivated by the story of this phantom planet, you must learn about the Tunguska event. The day a piece of the cosmos did explode over Earth with the force of 1,000 atomic bombs.